And now we're getting ready for the first topic, which is John. He's going to talk about IPv6 for home networks with his panel. Thank you.
Thanks, Nina. So I want to first like to thank everybody for coming here. Do a quick round of introductions. I had the pleasure of organizing this panel with some folks from the industry here. I'll start off by doing a quick intro, and then I'll kind of get into a little bit of a overview of kind of where this panel came from and say a few words, and then I will turn it over to these folks here. So first and foremost, we have, well, not foremost, but first we have James Woodyat from Apple. He is James is an internet dial tone and protocol standard specialist for the airport and time capsule at Apple. He started his career in communication software in 1988 and wrote his first original computer program in Data General Business Basic at the age of 9. We have Alan Hatari from Cisco. Alan has over 25 years of experience in the home networking and communications industry. Alan is a member of the home networking products team at Cisco Consumer Products, formerly known as Linksys, and is responsible for the investigation of emerging technologies and helping to define functional requirements for next-generation networking products, with special emphasis on wireless, powerline communications, and multimedia over IP. And last, we have Salah Nassar from Netgear, is a product line manager at Netgear, looking after business wireless. He has over 13 years of experience in the networking industry as a network administrator, technical marketing engineer, and a product manager. So I wanted to take a few minutes to introduce all these folks here. I'll kind of say a few words about how this whole thing came about. As many of you know, I work for Comcast, and we've recently announced earlier this year some of our plans to do a variety of IPv6 related trials. With our subscriber base. Now you can imagine that I got a lot of email about that. There's lots of questions. One of the things that it seemed like it was a natural thing to go ahead and do is to organize a panel like this instead of trying to reply unicast to 500 emails. So we were getting a lot of questions about what does the home network have to look like? What products? What this? What that? What protocol? What RFC? So this seems like a really good way, via a panel to kind of help get some of that information out and offer you guys an opportunity to be very interactive with the folks who actually build the products, and ultimately, myself included, to ask questions about how those things will work as part of those trials. So a bit of a shameless plug. If you have not signed up for our trials and you're interested, it is most certainly not too late. I should probably have a slide up here that tells you some more information about that, but I don't. The website is www.comcast6.net. So for anybody who is not aware of that, by all means, please check it out and let us know if you're interested. And we can explore the possibilities of including you in some of those trials. Briefly, what I'll do is I'll give you a little bit of an overview of some of the things that we are looking at from a trial point of view. Obviously, we've announced a number of different trial technologies, ranging from commercial dual stack through to a number of residential IPv6 related technologies. One of those, which we'll be starting actually very soon, is 6RD. From a Comcast point of view, we think that there is that the 6RD is a very good enabler for folks who have access networks that are largely not capable of native IPv6. They can't support native IPv6. From a Comcast point of view, it's not clear to us to what extent we will use this in a kind of production rollout. But we do think, but when we do talk to people who ask us for advice and want to kind of collaborate, we do kind of advise them that it looks like a useful technology, and folks really should take a look at it. The one thing that we have noticed is that there's still some work that needs to be done, particularly from a DHCP point of view, and maybe we'll get into some of that as part of the Q&A. Secondly, and certainly most centrally to our plans, are native dual stack residential over a DOCSIS connection. This basically is the type of scenario where you have a home router where your V4 is what it is today, it's unchanged, and we simply add IPv6 to it. So again, one of the things that you'll see here as part of this panel is, more information about products that support that mode of operation. And we really feel that that is a mode of operation that, is something that we like to use for an extended period of time, for as long as we can. Given that our network is largely capable of supporting that mode of operation, we feel that this is something that is good for us as part of our V6 deployment. And last but not least, we'll have probably some trials maybe towards the end of this year, perhaps into early next, for dual stack light. Dual stack light is one of those technologies where it certainly implies that there has been some sort of depletion event, and from our point of view, it's something that we look at as an insurance policy of sorts. And I think there's a lot of folks out there that while they're looking at different types of transition technologies, they hope to not ever have to use them in some way, shape, or form. I think for us, this is one of those cases. So with that, what I'd like to do is hand it over to the panelists. I think we'll start off with James from Apple. So if you wouldn't mind, James.
Can everyone hear me? Good day. My name is James Woodyard. I work for Apple, writing software that runs in the Airport Express, Airport Extreme, and Time Capsule products. I also participate in Internet Engineering Task Force efforts related to IPv6 transition. I'm here to talk about Apple's experiences using IPv6 for home networking and its products. Before I begin, I must regretfully tell you that I'm not permitted to talk about Apple's plans for future products and services. I would also caution you not to infer anything from my remarks as an admission of any particular technology strategy at Apple. I don't set policy. What I can give you, though, is a sense for how Apple engineers view the utility of IPv6 in home networks and what we are telling our managers about it. Hopefully that will be useful to you. If this isn't your first encounter with an Apple person on stage in front of you prattling about how glorious everyone's life will be after the revolution comes, then I'll forgive you for snickering at the quotation I put here. I wanted to start with this, though, because it nicely encapsulates my thoughts about how best to approach IPv6 transition planning, which, as a revolution, has been going on now for over 10 years. This is an Airport Express. It was a revolutionary network appliance when it was first introduced in July 2004, and not only because it had IPv6 inside. It's a Wi-Fi access point, a Wi-Fi range extender, a USB print server, kind of remote speaker for iTunes. You can plug your stereo into the audio output jack and you can stream music from your computer to it. It's small, it's inexpensive, and it does a lot in a very small package. But it's also IPv6 enabled. Did I have enough room on this slide for all my comments? I do not. That's what's going on. Hello? Okay. You can configure it and manage it over the network because we're Apple and we think different. We do this with Link Local Scope IPv6 and a service discovery protocol that we invented and called Bonjour. It's been standardized in IETF with some internet drafts. Why did we use IPv6 for this? Mainly because there's no way a normal person can screw it up. And I'm having difficulty scrolling my text. Why am I not able to do that? John, why can't I scroll the text? Oh, that's why. I will use this trick. You don't have to type IP addresses into crazy web forms. You can't use the wrong subnet mask and disable your whole network. There's no way to have overlapping private address realms. It works everywhere, whatever the network topology. It's simple, and at Apple, as you may have heard, we like simplicity. Now, that's all wonderful on a single network within your home, but I'm here to talk about the broader point of using IPv6 to simplify communicating over the internet at large. Here's something else we did with IPv6. Apple's Mobile Me service allows you easy access to all your email, contacts, calendars, photos, and files over the internet from, you know, the marketing text. One way it does all this is by allowing you to store all your files in Apple's data centers, but there's another way called Back to My Mac. Let me explain it in some detail. At first glance, Back to My Mac can seem similar to other services you may have seen. that allow you to connect back to another computer from anywhere and use it remotely. But on closer inspection, however, it's really a kind of virtual private networking service for MobileMe members. You give your computer your MobileMe username and password, and it joins a virtual private IPv6 network tunneled over the existing IPv4 internet. This allows you to work with your stuff using any particular application protocol just as if it were on your local computer network wherever you happen to be. For the technical types in the audience, I will give you a brief explanation of how it works. We tunnel IPv6 with unique local addressing over IPv6 and IPsec encapsulated security payload over UDP port 4500. We use UPnP IGD and or NatPimp to punch holes for the tunnels through NAT gateways, and we use dynamic DNS service update to make all the bonjour traffic go over the wide area internet. There are lots of other ways we could make these tunnels work, but this is what we've done so far. A side effect of how we did this is that for an application to work over back to my Mac, it must be IPv6 enabled. There's no IPv4 inside these tunnels. In macOS 10.5, Leopard, Apple went to considerable efforts to make sure that the most common applications our customers use work transparently over back to my Mac. All the screen sharing, or the sharing preference panel items. Further improvements came in 10.6, and it would be reasonable to expect more as the future arrives. The point I'm trying to make here is the user never needs to know they're using IPv6 to communicate. In some cases, because we've designed our application frameworks with this in mind, even the software developers never need to know which IP version they're using, modulo the comments that Lorenzo made earlier this morning. Now, that's fine for wide area networking inside the single administrative domain of a MobileMe user, but it's not the same as IPv6 communication on the full-scale public, administratively federated big bad internet. So, this is how the typical broadband ISP presents itself from my simple-minded point of view. Other kinds of residential service providers look pretty much the same, except the green boxes have different letters in them. Subscribers are connected over the distribution network from modems in their homes to access routers in their neighborhoods, and these route through a system of tubes to the public internet. In the usual case, at least in North America, this is all numbered with public IPv4 addressing. Each subscriber gets one public internet address, maybe more, but very often not. This address may or may not be persistent over time. Unless the subscriber directly connects a single host to a simple modem, they're almost certainly using a device with IPv4 NAT as their home gateway. It could be provisioned by the service provider, or it might be deployed by the subscriber themselves. It may or may not have an embedded cable or DSL modem. This is a diagram that one of my colleagues at Apple, Reese Schreiber, drew up a year or so ago to show what he had in his home network and how it was connected together. Aside from the unusually large number of Apple products, this is probably a pretty typical configuration for your average consumer electronics technology enthusiast. He enjoys IPv4-only service from his local telephone company, and his home gateway is a provider-provisioned IPv4 NAT router. The time capsule in the middle of the network is also configured as an IPv4 NAT router on purpose. In other words, there are three separate address realms here. The global internet address realm, the private realm provided by the two-wire gateway to the two Motorola VIP boxes, and the time capsule, and another private realm provided by the time capsule to the rest of the home network. Any host in my colleague's home network can have the same address as a host in my home network because they're both in different address realms, and importantly, none of these hosts are addressable over the public internet. Not just unreachable, unaddressable. And this is an important distinction. It means they can't send their addresses to services on the internet and expect them to mean anything useful. No callbacks, no referrals, not even when firewalls would otherwise permit communication. True, each host shares its public realm address with all other hosts in the home network. In theory, an application on a private host can be addressed by the combination of its gateway address and the public port mapped by the NAT to the private port on the host, and over the years we've engineered a lot of techniques for doing that. The result is a crawling horror of complexity, and I'll show you one of the more popular ways of dealing with that complexity now. This is the home page for a web service called portforward.com. When you want to use software that receives communication from instances of itself running on other hosts elsewhere on the internet, you often need to configure your home gateway to forward the application ports from the gateway's address in the public internet realm to your host's address in your home network. Every router is a little different in how you configure this. They all require the user to authenticate, which means remembering a username and password. Every application has different needs. Many of the applications that need to do this are multiplayer games, but that's not the only class of software to require it. The list of applications portforward.com knows about is 41 pages long. Today it's constantly changing. It's not even close to an exhaustive list. To make matters more difficult, some ISPs are faced with the increasing scarcity of IPv4 addresses. The IPv4 free address pool is running out, and once they're all gone, the registries will run out soon thereafter. To cope with this problem, ISPs have only two alternatives if they want to continue providing IPv4 service. A, stop growing their IPv4 subscribers, or B, deploy network address translators inside their network. Here's what that looks like to me. In this picture, the green networks are all still numbered in the public address realm, but the ISP is using network address translators to number their subscribers with private addresses, which I've colored orange. They're still assigning them only one address, so most subscribers are using network address translators at the demarcation themselves. And my friend Reese is using two. People like portforward.com will be having a field day with this. So will the ISP network operators whose management and provisioning systems will have to learn to cope with all the NAT traversal issues that residential users have been dealing with for years. But it will get even worse. There are only just shy of 18 million private IPv4 addresses. If you're a large ISP with 50 million subscribers, then you need more than one private address realm. If you've gotten to the point shown in this diagram, then you're now forced to experience the pain of NAT traversal just operating your own network. My guess is that this will be just as painful for you as for everyone else. So welcome to the revolution, comrades. We saved a place at the ramparts for you. I think it's clear that the transition to IPv6 is inevitable, and very soon the growth of the IPv4 internet will reach its natural limit. There's only so many subscribers you can reasonably make share a single IPv4 address before the internet is unusable over your network. And at some point, not long after the IPv4 address pool is exhausted, further growth for ISPs will be constrained by the failure to establish a functioning market for IPv4 address allocation exchange. It seems obvious to me that the further growth will only be practical by starting the transition to V6. The green, this picture represents what I hope most ISPs are planning to do, or at least I hope they're moving toward having a plan that resembles this. It's called dual stack IPv4 V6. Green part of the diagram is what you have today, and we don't expect you to dismantle it at any time soon. The blue part is the infrastructure required to augment your existing service with V6, vastly simplified. You may need network address translators to keep up with IPv4 demand during this transition, and your operations will not become easier just because you introduce V6 alongside V4. However, the dual stack V4 V6 service model permits the restoration of end-to-end addressability for hosts on the internet, at least for the IPv6 hosts. So when you sign up IPv6 subscribers, you assign each one a whole network prefix, not just a single address. And back on the ranch, this picture still looks pretty much the same. Some of these devices, like the time capsule and the iMac, for example, are already dual stack IPv4, IPv6 hosts. Is there an Apple TV on that? Boss? Yep. Yeah, that one's dual stack too. I just found that out a while back. My colleague Reese would probably want to configure his time capsule as a IPv6 router. He'd configure whatever replaces this two-wire gateway to delegate a prefix to it, and the time capsule would advertise it on its interface to the rest of the house. The dual stack hosts can be assigned IPv6 addresses by stateless auto-configuration. They might still use IPv4 for DNS unless they obtain IPv6 DNS server addresses by stateless DHCP6 or optionally by receiving them in router advertisements. The scope of IPv6 addresses in prefixes delegated to home gateways is global. No translators, no address realm conflicts. Address referrals between home networks and servers on the internet are possible again. Hosts can also use temporary addresses for a measure of privacy in the numbering of home networks. Privacy addresses all share the prefix delegated to the home network, so they identify the subscriber well enough for law enforcement, but not necessarily which host in the subscriber's network. If there are both IPv4 only and IPv6 only hosts on this network, then any communication between them will need to be mediated by a dual stack IPv4 IPv6 host. In a home network, this will probably not require a general purpose NAT 6.4 DNS 6.4 gateway. Simple application layer relays should suffice. So I'm thinking of things like 6LoWPAN and metering and things like that. Of course, for hosts that don't need to be globally reachable, like the Airport Express my colleague is using just for iTunes streaming, they don't need to assign themselves global addresses. They can just use their link local addresses to communicate locally. My colleague Reese, whose network you see here, probably wants to have a routed LAN in his home. He is that kind of gearhead. To make people like him happy, we'll want to carve prefix delegation from the service provider up into multiple /64 networks. Say, one for the LAN bridge on the time capsule in the bedroom, another for the guest network he makes available for his friends who come to visit, yet a third for the network that has all the sensors his power utility company wants to put in his house. To keep things simple for him, we'll need a way to automate the allocation of those prefixes, but that's not a hard problem. It is, however, unsolved at the moment. I should also mention that Apple will be releasing iPhone OS or iOS 4 later this month, and you may have noticed that current versions of iPhone OS don't support IPv6, but I hope that when you see what shows up on iPhone OS 4, that you will be pleasantly reassured. I did not admit anything yet. Quickly? Okay. If you want one of these gold-plated, you're going to have to do it. We don't sell them this way. The good news is that there's some transition mechanisms to make it possible for ISPs to ease into this business. I've got some slides here. I'm going to rush through them because the other panelists have much more to say about this than I do. We like 6RD, which is a great way to roll out v6 service without having to touch your access router or anything else in your existing IPv4 networks. You just need to bring up your v6 connection to the default free zone, deploy some tunnel relays, 6RD border routers, and then you need to upgrade all your subscriber gateways with firmware that supports 6RD. It's pretty easy. Free is an ISP in France that has done this, and it works great for them. And the IETF is moving to standardize on this pretty quickly. They've already gone to proposed standard, and the RFCs are going to be published pretty soon. The other protocol that we like is called DS Lite, and this is a better protocol for figuring out how you are going to begin the process of still providing IPv4 to your subscribers when you're going to an IPv6 only access network. And the way it works is it tunnels IPv4 through a large-scale NAT over IPv6. And you should consider it an exit strategy for dual stack. Go to dual stack first and then figure out how to remove IPv4 from your access network while still providing v4 service to legacy customers. And lastly, I have a slide that talks about basically how we think about this. Apple has been delivering IPv6 to its customers without you really knowing about it for quite some time. You might already have enough IPv4 addresses to last well into the next couple decades. You could continue doing this. You might be growing slowly enough that you never reach the limits of IPv4. You might just be culturally averse to taking new steps. In any case, Apple is busy helping their customers get IPv6 on their time frames and not service providers' time frames. And so we're going to look for ways to get IPv6 service tunneled over IPv4, and we're going to continue to do that. All of our application frameworks in macOS 10 and iPhone OS are protocol version neutral. If your application is on the iTunes App Store today, then it's probably IPv6 ready now, unless it is really, I was at WWDC last week, and most of the developers didn't even know or care, and only a few were looking at figuring out how to undo their legacy application code that looked directly at IPv4 addresses. So we're well past the point of no return for this. Thank you for your attention. Okay.
Thanks, James. Alan? Yep.
Was where? with a remote.
James, you have the clicker?
There you go. Hi, folks. I'm Alan Uterra. I work with Cisco Consumer Products, formerly known as Linksys. And I'm not here to talk to you about any product, so again, don't infer anything, blah, 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 about product roadmaps. And we're not, and we're specifically going to avoid products and talk to you specifically about a technology called 6RD that folks have been working on, especially in IETF. There's this button right here, right? All right, there we go. So to begin with, just a reminder of why would you consider IP tunneling at all? And you know, the basic truth of the matter is it retains end-to-end IP semantics. And you know, just keep that in mind that you know we're only touching tunnel endpoints. And also as a review, there's two different transition technologies being discussed currently today. One is, that James was referring to, is basically the dual stack light approach, where you're using IPv4 services over IPv6 transport. And that's what we're talking about in this slide deck right now, which is called 6RD, which is for rapid or a fast deployment. And, oh, okay. On that note, then why IPv6 and IPv4? So obviously, you know, deployment of a fully native IPv6 end-to-end would require numerous system components to change, and some of those are not very convenient. For example, like upgrading access nodes or other things in that part of the network. So doing a tunnel of IPv6 over v4 does provide a transition solution with a minimal number of quote-unquote touch points. Specific when it comes to 6RD, this is, as was mentioned in the previous presentation, a method for deploying IPv6 on IPv4 infrastructure. It is not a trial service, right? This, you actually get production quality v6 to subscriber endpoints. And you can reuse IPv4 infrastructure in the service provider network. You don't need v6 support in access or aggregation. You can get away without a IPv6 server. And you know, so for those of you who are familiar with it, and I apologize if you guys are novices or anything when it comes to IPv6, this presentation largely assumes some familiarity with v6. But for those of you familiar with 6 provider edge, this is similar to that. Now, in one slide, this is what 6RD looks like. And the critical part of this is to consider that two different components are introduced. One is called the CE, or customer edge, and it's typically located at the customer premises or in the residence. And the other component is the border relay, which is located on the other side. And that's where the tunnel is established between the two components. Prefix delegation automatically happens, and we'll cover that in more detail on a subsequent slide. But essentially, the core point here to take with you is that a simple and stateless encapsulation-decapsulation function occurs at both the customer edge and the border relay. Furthermore, border relays are deployed, can be or may be deployed. It's not necessarily obligated to do so using any cast, but it does. For those of you who are designing your own networks, you appreciate how that could simplify load balancing, resiliency, and other things. Also importantly, and we'll see this on the other slide, is that IPv6 traffic automatically follows v4 routing. And to reemphasize again, this really does enable dual stack v4, v6 service from the subscriber perspective. So 3 key points. One is that prefix delegation is derived from IPv4, derived or calculated if you look at the draft. This reiterates some points we had on the previous slide, but again, there's no need for v6 on the residential gateway WAN interface. You don't need a IPv6 server in the network. You can make this work with either global v4 or NATed IPv4. Really importantly, too, there's no subscribers tunnel state or provisioning. It's really boils down almost purely to a routing problem. So let's talk a little about the prefix delegation. Here's 2 different examples, and don't necessarily, again, I want to emphasize that these are just examples. There's a lot of flexibility in this technology, and we'll illustrate some of it here. But basically what you do for the IPv6 prefix is that you've got the classic part on the left there in green, and this top example is the /28. And then you provision it, all the blocks also with the RG, also with the customer's IPv4 address. Those 2 combined are what makes the prefix delegation, right? Now, the number of bits you use there in the prefix can vary depending upon what you're doing with your deployment. What's important to realize is that what's here shown in the green and the blue has got to be the same in the RD domain, right? You could use, like I said, like here /28 or /32 and however many bits you want from the IPv4 address part of it. As long as those are the same in the particular RD domain, you're implementing this. And for those of you who are familiar with 6-4, one big difference is that it was a classic, well-known /16, right, on top of it, yeah. Okay, anyway, but let's take a look at an example of how this works in practice. So, on the top of the top path you see there in the dashed black line, and the bottom is the blue line. So on the black, this is if your prefix that has a positive match, basically you route from one residence to another residence. If it doesn't match, which is in the blue, you forward it to the border relay. And in discussing this, okay, so I don't work on this as part of my day-to-day job, right? There's other guys in Cisco who work on this. And in learning more about this, one thing that we've come up with to try and explain this to people how this works is, if you're having problems understanding this, it's like, think of this RD domain as being this like one great big huge giant residential gateway. Instead of single Ethernet ports for devices on the customer edge side, think of like each home as being like an Ethernet port, and then these 6RDVR is like the WAN port. And you kind of look at it and go, wait, that sort of makes sense. It's sort of a weird concept, but thinking about this as like a great big huge exploded gateway, you sort of get your head around what's really happening here, and then it becomes pretty straightforward, and it's pretty simple and pretty elegant. Diving down a little bit into the customer edge component itself, again, there's four main things that you have to have the same in the RD domain. And referring back to the previous slide on the prefix delegation, you have to have the same IPv6 prefix and length, a common length for the IPv4 bits, and then a known address for the border relay, which is more than likely to be anycast. This can work actually with a NAT also. I mean, that's not to advocate it necessarily. In fact, I don't know if anyone would really be advocating that, but the fact remains that this can work. And the RG, the LAN site itself is configured of the residential gateway is configured for v6. And one note, just for those of you who have the implementation questions, the RD draft doesn't really get into details about how you implement the v6 provisioning for devices in the home itself. Diving down a little bit more into the components on the residential gateway, again to reiterate, the subscriber endpoint device side is expected to really be dual stack and allow services that are running on v6 to be delivered to those devices. On the WAN side, this permits the service provider network to evolve at its own pace. And you'll sort of see it on the next slide. In theory, the border relay that's shown on the far right here could migrate to the left, closer and closer to the residents over time, and thus transition you to a full v6 network. Again, to reiterate on this slide, the important points are that the border relays themselves also have to be configured with the same v6 prefix and length, common IPv4 address, and be able to respond to a border relay address. Now, as James mentioned in his presentation, this is in ETF standards track right now. It's up to draft 10. I'm not sure if it was, I'm told it was draft 4 that was actually approved by the IESG last month, but I do know that they're up to draft 10 now. This is really, it's a good document to read if you want to be familiar with it. And I guess the goal of this presentation is if you walk away with this with more questions and answers, it's a good thing. We're really just trying to make you curious in what 6RD actually is. To wrap it up, here's a summary of some of the pros and cons. I won't read these to you because you've got a copy of these via NANOG, but I think the real important part of this is that you're using v6 in a method, a simple method that allows you to transit a existing v4 infrastructure, and you don't necessarily need to deploy a lot of changes to your network in order to get v6 services to your subscriber. There is a penalty. Obviously, there's some extra overhead from the encapsulation because it is a tunnel, and continuing to use public IPv4 doesn't actually solve v4 exhaustion, but it does appear to be an effective transitory mechanism, especially for providers who have a lot of difficulty in upgrading their existing network to V6. And with that, that's enough on that. And next presenter.
Thanks, Alan. So I'd like to have Salah come up from Netgear. And
thank you, Alan. Okay, we're going to change it up a little bit. I'm not going to talk technology. I feel like I just got a CCIE in IPv6. Thank you for that. Very educational. I'm going to look at it from the ground up. As you all know, Netgear has a very strong consumer presence, right? Some people have Netgear at home. Some people have Netgear in their business. We also work very closely with service providers. That's why we're here. So what does IPv6 mean for Netgear? For Netgear, we looked at it a few ways, right? First, we look at what does the consumer want. And how many consumers out there do you know that are looking for IPv6? If you go out to the average user and you say, what's IPv6, they'll probably tell you it's why R. Kelly went to jail or something to that effect. Right? So IPv6 doesn't matter for the home. All they care about is that they have all their home applications, all their networking applications, whether they just bought a new iPhone or a new Apple laptop or whatever product it may be, whether it's from Netgear or another consumer company, they want it to work. So how does Netgear deal with that as well as deal with the change? So IPv6 is kind of a change. It's not necessarily an application. There's nothing sexy about IPv6. No one is running out to the stores. No one's going to wait in line at Best Buy to get any IPv6 products, right? It's kind of like security. There's been a hole in the network, and now we're running to patch it. And that's really how IPv6 is viewed by Netgear. So there's this problem out there that we need to patch. So how are we patching this? Right? So there are a few ways we're looking at patching this. We're looking at, first, we're working with our service providers. Well, how does Comcast want to tackle IPv6? Because really, at the end of the day, we're more in the reactive position, aren't we? It's kind of like security. When something bad happens, you have to react to it. So how do we react to IPv6? Well, clearly, the first thing we need to do is make sure that it's 110% transparent to the consumer. The consumer should not have to speak IP at all. The consumer should bring a product home, they should turn it on, and they shouldn't know if it's running IPv anything. They should know that they can turn it on, it can connect to the internet, and it works. Now, that's a bit of a challenge for us on the networking side. It's a bit of a challenge for the service providers. From the networking side, we have to wait and kind of listen, see what service provider wants to do. From that end, what we have to do is be able to react. We have to give service providers the right management, right? So that means we might have to have a dual stack IPv6 and IPv4. We don't have necessarily a position on do we care if we NAT, do we not NAT, do we protect the end user nodes. That's really not something for Netgear to really make a decision on. From a security perspective, it's a little difficult to tell what security is going to look like in 6 months, right? Does anyone know how they're going to hack in 6 months? Anyone know what new viruses are coming? No one knows, really, so it's kind of a reactive thing. And my point there is that when it comes to IPv6 security in the home, I can bring on a little bit of what we know about in the small-medium business. And small-medium business is just a hairline above the consumer level of understanding for networking. And what that means is we're going to need some sort of a layered networking defense, right? The more you expose your addresses directly to the internet, the more you're going to need a layered defense. And when we're looking at future products, we're looking at what kind of layered defense can we put in there. What's a layered defense? Layered defense is, okay, we're going to do the basic firewalling, right? We're going to block off at the internet connection. We're going to make sure that people can't do the basics. They can't DOS attack you. They can't do brute force. They can't do the basics, right? This is welcome to like 1989 hacking. We're going to make sure that doesn't happen. But on top of that, we're going to also try to make sure that you don't have any spam. We block the spam, right off the bat. We're going to make sure that we try to block the viruses right on the edge, right? And we're working with service providers. We have products that will work with in the service provider network where maybe the consumer doesn't have to worry about that. It's a service that they buy through the service provider, or we have it right on our edge router that will take care of it. So as far as products go, we do have the ultimate networking machine. Anyone familiar with this product? It's a dual band. I shouldn't even say dual band. It supports both 2.4 gigahertz and 5 gigahertz wireless networking, and from the back end, it just does everything for you, right? It does storage, it does security, and it does all your basic networking stuff. Why do we have to have this type of product in the network? Because the home network is very complex these days. As we saw from that Apple network, that is an he must have needed someone with a CCIE to configure that network. Everything works together, and that's really intimidating for the average home user. That's why you have companies like Best Buy with their Geek Squad that are charging an arm and a leg to go to your house and configure it, because networking is still a scary thing for the consumer. However, everyone wants everything connected. Okay? If I buy an iPad, I want it to work with everything in my home. I want to be able to pull. If I buy a Netgear storage device, I want my iPad to read all my images and music and movies off of that Ready-NAS device. If I put a storage device in my router, I want to be able to watch it on my TV. If I'm watching something on my laptop and I decide I want to see it on the big screen, I want to push a button and watch it on my screen, right? And obviously I'm talking about Netgear technologies that we have going right now. So that's a bit of a challenge for us. So what does IPv6 then mean for these networking products, right? There's the how does a product, let's say my storage device is IPv4, but my router runs IPv6 and my iPad is running IPv6. How do they communicate together, right? That's a bit of a challenge, right? That's a bit of a challenge. How does everything talk within the network? What's that going to mean for the processing power of some of these devices? Are they going to run extra cycles just so they can so they can process this traffic? How is that going to affect critical data such as video or voice when you're running both IPv6 and IPv4? So these are things that we don't have an answer to. These are challenges that we're looking into, and the more we see how exactly our service provider is going to implement IPv6, it's really quick for us to turn on it. So our theory behind IPv6, or philosophy right now, is that we want to run IPv6 and IPv4 concurrently. We don't want to NAT from 6 to 4, even though we know it's going to be half a decade from now before every product in the home has IPv6. Let's be realistic, right? People are not going to run 100% IPv6 networks in the home for quite some time. Matter of fact, I have a PC at home that I've had for 10 years, right? There are going to be a lot of people who are going to maintain devices that are running IPv4 for quite some time. So the interoperability of IPv6 and IPv4 is going to be a challenge, an easy one to solve. It's just a matter of how do we slice it and dice it and get the best application to the end user. Because again, at the end of the day, all we care about, we don't really care how Comcast implements IPv6. We don't care what they're doing out in the cloud. All we care about is that when a customer buys a Netgear product, that they can plug it into their home network, plug it to their Comcast device, and it's seamless. Okay? Again, you know, the way the consumer home is now, it's a lot more advanced than it used to be even a year ago, right? Everyone wants connectivity, everything that they have at home. They want it all to interoperate. They want to be able to go to Starbucks and still view their media on their home device at home, right? I mean, who has a Sling box, who has a Ready-NAS box where you can view your pictures or movies or whatnot from anywhere in the world, pretty much, right? I was actually watching a Sling box show when I was on a Lufthansa flight over to Europe. I mean, here I am on a plane. I'm watching my show in 30,000 feet above the ground or whatever it was. So connectivity is really what we're looking at. And at the end of the day, I'll reiterate this one more time, transparency is what we care about in the home. Interoperability between products, the home network, and the service provider network, it should be transparent and seamless. Okay, so I hope that you guys will have some questions for us on how we're planning on doing that or what we're planning on doing in the future. But please look at, are you familiar with Netgear.com? right? We're constantly pushing out new data as we present it. So if you have questions, we have many forums. Please visit our forums. We'll be more than happy to chat with you then. Thank you.
Thanks a lot. All right, folks. So now is a good time for you to ask some questions. Yeah, I trust that no one will be shy here. Certainly not what I'm expecting. Dave, could you name and who your affiliation?
Yeah, Dave Meyer, Cisco, UVO. I was wondering, with these tunneling technologies like 6RD or any of them, Lisp, any of these ones, what do you folks perceive basically the PMTU issue? Do you perceive it to be threatening to these technologies or not? Have you had experience where, oh, well, you shoved one of your encapsulated packets accidentally down a GRE tunnel and it exceeded the PMTU and never came back like that?
I can make a comment unless you guys want to go first. I mean, I think based on what we're hearing so far with experience, that's going to be an issue, right? But I can tell you that one of the reasons we are absolutely trying to get our trials, started as soon as possible, is those are the type of learnings that we're going to peel out of that, right? My assumption at this point is there'll be something there that could potentially be an impediment, which again largely is why we're saying, native dual stack for us is central, and we know that our entire network is natively capable of IP6. Unfortunately, I can't account for what happens once it leaves my network. But again, so my feeling is when we come back in Atlanta, I hope to have something more detailed to tell you about that.
Can I add something?
Absolutely.
So the technologies that we've been talking about here, 6RD and dual stack light, both of those tunneling technologies are aimed at not really crossing any exterior gateway border boundaries. So if you have path MTU discovery problems, they're going to be pretty much local to the administrative domain where you're trying to run the tunnel. Both endpoints are inside the same routing domain. It's not like 6to4 or Teredo, where when you have a path MTU discovery problem or a black hole in the network, you have operators pointing fingers at each other saying, it's your fault, you should fix it. No, it's your fault, you ran a tunnel. That shouldn't be a problem. You'll have problems, but it'll be problems you can control entirely yourself.
Yeah, the reason I asked was because with those technologies that basically, 6/4 of any variety technologies that have to traverse the internet, I've seen a lot of PMTU issues. Like, I'll just give you an example. There was one place where somebody was using a GRE tunnel to get BGP so they could hop over their access provider, right? And so one of these packets went down this tunnel, and that was that. And so that was only 2 encapsulations.
Yes.
So,
That's a way that you can have problems, but both of these tunneling techniques are designed for production use. So,
Next question.
Lee Howard, Time Warner Cable. Thank you all. I'd like to see a lot more of you. First question for Salah about the Gearport Extreme, whatever that box was called. That's a very high-end box. Love to see it. Glad that you have a product announcement for us that says it supports IPv6. Anything on the lower end of the spectrum that might support IPv6 for my cheaper customers? Excuse me, our cheaper customers?
Okay, well, to answer that question first is that Netgear has never been known to be the cheapest product out there. With that being said, no, we currently only have 2 routers. If you want specific product numbers, WNR 3500 and WNDR 3700. One is version 2. You'll see the new firmware coming out within the next 6 months. It does not currently support it. So in the future, yes, you will see those 2 products specifically drop down heavily in price. So for the cheaper customers, that will be the solution.
Before somebody else steps in line, I wanted to ask Alan from Cisco Consumer Products, formerly known as Linksys. On your list of cons to 6RD, I did not see have to replace the CPE, the gateway router. Maybe to you that's not a con, but it probably is to me and or our customers.
Okay.
I'm sorry, so that's a pro for you?
I think replacing hardware is probably a pro for the vendor of the hardware, but not for the person who's buying new hardware.
Sorry, Alan, go ahead.
No, I was just saying, well, replacement, if it enables a new service, that's a good thing. But I understand what you're saying, but it's hard for me to wrap my head around how it's necessarily automatically a con to put new hardware. I guess I would say that if that was the only feature that was in the box, that's one thing. But since it would be unlikely that any hardware vendor would have that be the sole feature or reason to replace a box, I just I can't see it as a con.
Gentleman in the front here.
Yeah, Jay Hennigan with Impulse Advanced Communications. We're an ISP. We're presently dual stack. Our residential customers typically delivering to them via DSL over an ATM aggregation circuit. And we're presently completely dual stack V4, V6. I go into Best Buy or Fry's or what have you, and I see hundreds of products in the sub $99 range, some sub $49 as home router, quote, router devices, all of which have V4 NAT, some have access points and what have you. Does anyone know of any one of those devices that I can go into Fry's today in the sub $99 range that will take my IPv6 addresses that I'm advertising via RA and DHCP v6 and have my customer plug in and take advantage of the dual stack network we've built? And if not, why aren't you people making them?
I don't think that's a question for me. Anyone?
Does anyone else have any products in that range?
I don't.
Well, then I can volunteer to answer a little bit.
So Jay, what we ought to do is, I know some, but we should probably talk out of band. I can give you some insight there. So, in the back.
The question is, for someone who knows more about their product line than I do, does the MikroTik 750G do that? And the question for Fry's is, why aren't you carrying them?
I don't even know what a MikroTik blah, blah, blah is.
You don't know who MikroTik is?
Nah.
Oh, see me afterwards.
Okie dokie.
They're good ghetto routers.
Awesome.
Yeah, so to quickly answer that, Joel Yegley, Nokia. I don't work for these people or sell this product, but the D-Link DUR 825 will do it today.
Thanks. Next question.
One philosophical question. Nick Weaver, ICSI. As a security person, I love NATs because my mom can't screw it up. Her computer is not reachable from the internet is a feature, not a bug. And I'm wondering how IPv6 deployments, especially with the vision of companies like Apple and Netgear and everybody else of having these home devices that are once again internet reachable, is going to do to my mom's security position.
Hey, so we took bets. We took bets whether this question would come up or not. All right, so let's go.
Yeah, I can. If you don't mind, I can jump in and answer that. So from a Netgear perspective, you're absolutely right. As you know, as you may know, Netgear has recently also entered the security market. So we entered that in the service provider as well as the SMB business, but we're not ignoring it in the home business at all. I kind of alluded that a little earlier that we're going to look at network security on a layered defense for the home, and at the end of the day, it will be 100% transparent as much as we can. So that way, when your mom or your grandma or your sister or your cousin buys a Netgear product, plugs it in, they are just as secure as they are today behind NAT. I'm not going to say that we are using NAT or not going to use NAT yet. However, that is one of the main discussions is how secure will IPv6 be without NAT, and is it and how resource intensive will it be to NAT it as well as add security, or to unnat it as well and add security, and make it 100% secure as well as seamless.
So why not just use a firewall?
Well,
Do you want to explain to my mom how to configure a firewall? That's the point.
It's one checkbox.
No. No, I don't think you can tell a consumer to turn on a firewall. The conversation of a firewall with a consumer is not one that should be had, just as the conversation of the difference between IPv4 and IPv6 with a consumer should not be had. It should be automatic, and as the industry sees fit for security, we should automatically implement that in there without asking the end user whether they want the extra security or not. They can uncheck it if they want, sure. We shouldn't ask them to check extra security if we know beforehand they will need it.
Next question?
On the side.
On the side?
Yeah, Michael Sinatra, UC Berkeley. Notwithstanding Nick's desire to keep his mom off the internet, I was wondering, particularly in respect to the Apple presentation, I did see some interesting references to the use of DHCP-v6 to get network configuration information. I was wondering, without making any forward-looking inferences, am I to assume that there is some, or not assume, just am I to be interested in whether or not Apple has some interest in supporting DHCP-v6? Because not only in the home market is that very important, but I think it would be very useful in the enterprise market as well. And I'll just leave that as a comment, since you probably can't say anything more about it.
Actually, let me try to say something about that. For a long time, Apple has resisted adopting DHCP version 6. Those of you who've been to Internet Engineering Task Force technical plenaries in recent years may have actually seen Stuart Cheshire stand up and announce that Apple will never do DHCP v6. I think that was premature of him to say that. I, of course, can't tell you when it will be showing up, but I think if you do some Google searches on things that have been leaked by iOS 4 developers that they're not supposed to show, you might see some things about Apple's approach to DHCP-6 that may show that our engineering people, our CoreOS networking people have been shown the light on the subject, and our story should be getting better. It's not better yet, but it will be better soon, I think.
So we have to close the mic to these two guys up front here. Next question, Lorenzo. Who are you?
Lorenzo from Google. When was the last time you had an exploit that came in through the network? Browsers, the exploits come in through browsers these days, and that is not helping you. And lest I be caught making unsubstantiated statements here, please read the paper. I forget what the Configure botnet, perhaps. If you and the researchers looked at the IP addresses of all the machines in the botnet, 80% of them were behind NAT. NAT didn't stop the botnet, and it's just not going to help.
Same position, different argument, though. If, like Joseph, Google as well. If you want to really, and this is channeling a few others, but if you really want to implement proper security for your mother, you're going to have to do it at the host level. You're going to have the host decide whether it's going to accept certain connections over global unicast versus link local. You may not want your printer exposed to the internet, but you're certainly not going to get end users that are going to be willing to change anything, whether it's turning a bit on or off. If you don't believe a user can properly configure your firewall, then they're not going to be able to configure the firewall to allow Skype to work or to allow BitTorrent to work. So it's going to have to be the operating system and the application level that are going to have to indicate via their selection of addressing what security policy they want to adopt for that particular connection.
Can I add something to this as well?
Sure.
So I'm the the technical editor for an internet draft in the v6 Ops working group called the IPv6 CPE Simple Security Draft, which purports to explain in somewhat precise detail how you would go about implementing a simple stateful firewall for residential gateways. If you're interested in looking at equipment that supposedly has a simple security firewall, compliance with that draft when it's completed would probably be something you're looking for. The basic idea in this draft is that it replicates all of the brokenness of NAT without actually translating addresses. If that's something that you feel you need in order to keep your network safe from the terrorists and the barbarians, then that's what you should have. It, I think, quite wisely suggests that you should allow certain specific security protocols inbound access to your network, and it currently says that it should allow in Internet Key Exchange, IPsec authenticated header, and IPsec encapsulated security payload, which should be allowed because those things are supposed to be secured by other means, and we kind of made a decision in the design team to allow that, but vendors might want to even turn that off too. So if you look at the airport products that I work on, you'll see that when you enable the IPv6 forwarding mode in any of its modes that it supports this, there's a checkbox that you'll see that is the block incoming IPv6 connections checkbox. It's enabled by default, and it tries to comply as closely as possible with this draft. And the good news is that if you find that it's breaking your app, you can turn it off, whereas you can't really turn off a NAT.
So we're going to have to wrap up here. I have 3 closing comments. First, one of the intentions of this panel was to clearly illustrate that there is there are folks out there who are doing work in the space. I do want to make mention. Last week, Google hosted a conference. We had another panel there that you guys want to learn more about. A whole other set of vendors that are also doing things V6. You should go Google it. The second thing is we are having a vendor collaboration room, which many of you have probably seen in the VCR. Please stop by. There are many things that we have enabled in that room related to what you heard up here today. We would love for you to stop by, take a look, talk about it, ask us questions, and even in some cases give it a try. And lastly, related to the vendor collaboration room, we are actually having a drawings for some giveaways. We had our first one today, and we'll be doing one each of the next 2 days until NANOG is over. All you have to do is leave a business card with us, and you'll be entered in the drawing, and we'll find you. So please, give a round of applause for these guys here, and thank you.